everyone, it's Coach Fred here, and I'm going to be talking today about different ways that we can represent data. And so this is section 1.5 in your textbook. And remember, I'd like to see your name, your date, and the section on the top of your notes. First, we're going to actually go through a bunch of vocabulary, and I'm going to make sure you know what the terms mean so we can use them. So a set is just a collection of objects, and each object in the set is called a member or an element of the set. Typically, what we do to indicate sets is we use something called braces. Braces look like this, and they can be very hard to draw. So sometimes, in lieu of braces, we might use parentheses. The problem with that is that can confuse us with other things in math. So if I say that we have a set, I'm going to say we have set A, and in the set we have the numbers like 1, 2, 3, 4, and 5. We could say then that A equals 1, 2, 3, 4, 5. And so we know that the numbers, the objects in this set, or the members of this set are 1, 2, 3, 4, and 5. All right. We can also have equal sets. Now, if I have the set 1, 2, 3, 4, it would be equal to 4, 2, 1, 3. The order in which you put them doesn't really matter. They're still equal sets. Although in math, it's actually usually good to go from least to greatest. All right, now we have something called the solution set. So the solution set of an equation is the set that contains all the numbers that are solutions to the equation. So if I give you the equation x squared equals x, okay, well, it is a quadratic equation, so we could solve this equation by setting everything to 0. Then we could solve by factoring it. Factoring it, we take out the greatest common factor of x, and we'd be left with x minus 1. Now we'd use the zero product property to set each factor equal to 0. By doing that, we get our answers of our solutions of 0 and 1. To write that as a solution set, we would write our braces 0, 1. Okay? Now, the reason I like to use the braces other than parentheses, if I write parentheses 0, 1, you might think of it as something different. You might think of it as a ordered pair. An ordered pair contains two elements in a designated order, always the x coordinate first and the y coordinate second. Think of it as your input and your output to a function, okay? When you think of any point graphed on the coordinate plane, it must be an ordered pair. So you might say 2, 5, but I need you to make sure that it's not the same as 5, 2. So if I draw a quick coordinate plane here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. 2, 5 would be along the x-axis 2 units and up 5 units. So there's 2, 5. It is a point. And then 5, 2, though, would be along the x-axis 5, and y of 2 would be here. So those are different locations in the coordinate plane. Okay. All right. So something that's important for you to know is the origin. Okay. The origin is the name of a special ordered pair. If I tell you something passes through the origin, you need to make sure you realize that the ordered pair on that line would be 0, 0. Okay? There's actually some other points we have to be very careful with, and we've talked about it in class, but I want to specify it here. The y-intercept and the x-intercept. These are coordinate points. These are ordered pairs. But for some reason, when you learned about y equals mx plus b, and I asked you the other day what the y-intercept was, many of you told me it's b. The y-intercept is not b. 0b is the y-intercept, where it crosses the y-axis. And an x-intercept would be whatever the x coordinate is, 0. It has to be written as an ordered pair. So anytime you see y-intercept or x-intercept, I need you to think of it as an ordered pair. Okay, last thing I want to talk about today is matrices. A matrix is a way to organize data or numbers into rows and columns, and we use brackets. This right here has got one row, so this would be row 1, and it has 2 columns, column 1 and column 2. This has 4 rows, so row 1, row 2, row 3, row 4, and 2 columns, column 1, column 2. So this we'd call a 1 by 2 matrix. This we'd call a 4 by 2 matrix. So matrices are always given as rows by columns, if I tell you how big it is. If I asked you to draw a 2 by 3 matrix, you would draw brackets, and it would have 2 rows, so row 1, row 2, and it would have 3 columns, column 1, column 2, and column 3. So 1, 2, 3, 4, 5, 6, and there's a matrix, okay? All right, so now let's look at some examples using these. So it says, choose from the set 0, 12, 24 to solve the equation. So this does not mean solve the equation using algebra. This means solve the equation using substitution. So, and verifying if the equation is true. So remember that equals means is the same as. Is the same as. Okay, so let's try it. If I take the 0 as a set, a solution, we plug in 0, we get 0 over 6 plus 3 equals 7. Well, 0 over 6 is actually 0, and 0 plus 3 does not equal 7, so 0 is not a solution to this equation. It does not make the equation a true statement. All right, 12. 12 over 6 plus 3, is it the same as 7? All right, well, 12 over 6 is 2. 2 plus 3 is not the same as 7, it's 5. So 12 is not a solution to this equation. All right, 24. 24 over 6 plus 3, does it equal 7? Does it make the equation true? Is it the same as 7? Well, 6 goes into 24 4 times, so 4 plus 3 equals 7, so 24 is a solution. That's how you can use a set to determine if it is a solution to an equation. All right, you also have to be able to understand ordered pairs. So this question says if x1, y1 is 6, 8, and x2, y2 is 14, 32, they're just giving you different ordered pairs. Solve for m in the formula. All right, well, we would substitute in 32 minus 8 all over 14 minus 6. So we would get 24 over 8, which gives me 3. I'd now like you to answer the 3 questions that I gave you in your notes, and we will go over those tomorrow in class. I also would like you to read why on the next page, all the information in the box, and we're going to talk about that tomorrow. All right, but let's look at example 3. So the matrix below gives data about hats and scarves in a store. So I'm going to call them hats. I think I might have written it as caps, sorry, and scarves. This is a matrix. Matrix gives us real information about real data. So I know that right now I have 5 red hats, 8 blue hats, 3 yellow hats, 6 red scarves, 4 blue scarves, and 9 yellow scarves. So you can use this matrix to answer questions. The number in row 2, column 3. So row 2 is this row, column 3 is this one, so is 9. What does it represent? It represents 9 yellow scarves. The sum of the elements in the second column. Okay, well, this is the column. The sum of them would be 8, 9, 10, 11, 12. So that would mean that we have 12 blue items. The sum of the elements in the first row. Okay, so the first row is hats. So the sum of those elements would be 16. So we have 16 hats. Okay, a couple more. The sum of elements in all the elements in the matrix. So 5 plus 8 plus 3 plus 6 plus 4 plus 9. I think that gives me 35. So there's 35 hats and scarves. And that's how you read and interpret a matrix. Now we're going to be doing more with that. But to ensure that you understand what we've done, I'd like you to now go to page 27, and I'd like you to do numbers 3, 5, and 6. You will put your name, date, and page number at the top. Work on the left side, work vertically, show all your work. You're going to turn those in tomorrow to make sure you understood what you learned today in this video. All right, guys, hopefully that was helpful. Have a great day.